Hello, and welcome to the Anexinet Infrastructure Modernization Podcast. Here on AIM, we invite industry professionals and subject matter experts on to discuss current trends and technology topics. Today, we will be talking modern network and security with Infoblox. With me is my ever-resilient co-host, Dave. How's it going, Dave?
It's going great, Chris. Thank you.
And from Infoblox, we have Michael Katz, Security Specialist, and Jim Zelnosky, Senior Solutions Architect. Gentlemen, how are you doing today?
Great. Happy to be here.
Yeah, it's nice to be here.
So let's start from the very beginning. This company has been around for a very long time, and you started out doing what some would consider some basics around how an organization supports its own resources, and that is DDI. Can one of you describe, first of all, what DDI is and how Infoblox started in managing that space?
Yeah, sure. This is Jim. But I guess I'm the best one to talk about that since I've been with Infoblox for 10 years. So I've kind of seen us grow up until where we are today. DDI is an acronym which stands for DNS, DHCP, and IP address management. It was actually coined by Gartner and it was tracked by them. They started tracking about 10 players in the market over the years. Some of them have dropped out. It's not a extremely well-known market because actually something that's in the control plane of a data center where you have elements that you're not passing data through, but you're controlling actual data and what it's doing. For example, you're giving out IP addresses through DHCP. And one of the things that needed to be done was tracking of those IP addresses as there was explosions with Wi-Fi and other types of IoT devices, Internet of Things that have grown up over the years. It just became difficult to handle on a spreadsheet. So a lot of our customers that we started with were using Excel spreadsheets. They had issues with too many people touching them. They were never up to date. They were never trusted. So people, basically just didn't use them. So they needed something that actually would bring that into a relational database where you could put extendable attributes about where information was, where the equipment lies, what users are responsible for it. Also things like tracking who's making changes. What did they change? If they made a change, can you recover or bring that stuff back into the database? And then, just making it much more easier from an operations point of view to manage your network, which was really, an IP based environment. So it goes across all verticals.
Right. It's funny that you said it's not this well-known area of security. And then your follow-up to that was, but, you're still sending data across your network. It's amazing to me that we still have to explain that concept to people. If you're transmitting data, that has to have some sort of risk associated to it. In this day and age, you just have to assume that it's there. And since IP addresses are what allow our systems to communicate effectively using modern technology, you're going to want to protect them and know where they are and what's happening to them. It just amazes me. Like, why isn't that table stakes this day and age?
I worked at Infoblox and I took a break and worked at some pure cyber companies. And, what I found is that a lot of the security, people per se don't have an IT background. They'll come from law enforcement. They'll come from military where they were doing, working in signals, or they'll come from maybe a more secret branch of the government. And they're just not thinking about infrastructure. And I think that's one of the areas that really contributes to this lack of knowledge. And then the other key area is there's a lot of marketing stories out there, and I think a lot of people sort of buy into the idea, if I buy this thing, my problems are solved. And I don't really need to look further because, hey, they've told me that my problems are solved.
Ooh, I want to talk about that. Tell me more about that. Do not stop. Speak.
Well, there's a lot. I think a lot of the cyber strategies are around, hope and prayers, right?
We're going to pull on this. Get specific with me. Which cyber strategies are hopes and prayers? Please, this is good stuff.
If you buy a certain type of device, say you buy a firewall, right, that has all types of different feature packages that you can add on to it, that it's going to do what it actually says.
Sure, I'm in next gen firewall licensing, eighth circle of hell.
Right.
I know. I'm with you.
There's a couple questions I think that you have to ask yourself. Is one, how many ransomware victims that you read about, how many of those have firewalls? And how many of those have the firewalls that are making you the promises that they have a, complete security perspective? And the answer is every one of them have firewalls, right?
Oh, man, I was really hoping that you were going to let me do that dramatically.
All right, go ahead.
Every one of them. Every single one of them.
Yeah, everyone has it. And then the other thing is that, you have to assume that if you read about 10 companies and one company's, selling, most of the firewalls, and probably most of those 10 companies have the same firewalls. But nonetheless, for some reason, people, they used to say nobody gets fired for buying IBM. And when I was at Cisco, we tried to appropriate that saying. Nobody would get fired for buying Cisco. It comes down to a lot of marketing and security. People say, well, if I buy this vendor, then, I'm buying the best, and the board and my executive management's not going to question me.
I have to say that, being here at Infoblox so long, when you now own more than 50% of the market, there's a reason. Why is that? And it is because, most data center network buyers are saying, I'm going to buy the best. I'm going to buy the stuff that never fails, never goes down, always works, and I'm not going to lose my job. I mean, kind of like the old IBM concept, right? But reality is it's true. And people continue to buy our product because of that, and why they don't use standard Microsoft, which is embedded in every operating system for DNS and DHCP. We just have a better way of doing that. And we keep improving on that.
I think that point is really important to reinforce. One of the biggest things that happens if people or organizations are left to their own devices, no pun intended, is that they accidentally create, for example, overlapping DHCP address ranges. And then you have IP conflicts, and your devices can no longer communicate if something accidentally has the same address in engineering as it does in finance. So at the very, very basic level, it's about making sure that every device has an IP address that is valid and is not in conflict with anything else.
That's absolutely true. And, when we first started out, it was really kind of just swapping the Excel spreadsheet for the relational database and more metadata to work with there. But it was still kind of static, and you had to kind of like, hey, we got to build some automations in to make sure that there aren't these type of conflicts. And then we have some more visibility of what's going on out there. I mean, what is in the network? I mean, how many customers do you go into and you say, hey, what do you got in your network? Well, pretty much got, these many networks and routers and switches, and, we kind of know how many IP addresses, but they don't really have their arms around it. And we've really done a great job in creating more automation around discovery and trying to eliminate those types of conflicts and giving people the metadata. And, this is a great segue actually for, Mike to kind of talk about how we've taken that into security.
Yeah, I mean, I think from a security perspective, what makes Infoblox different, doing identification of assets from the IP address phase, the first entry onto the network, and then from doing security from the DNS metadata, is that we don't have to see every packet, right? You don't have to have two, packets coming in and out of our system in order to audit what people are doing, to enforce policy, to detect malware, to contain a device, right? We can do it just from the basic foundational services. And DNS is layer 7, right? It's an application. Same with DHCP. Those are applications. So it's very different than a firewall that, even though a lot of them, do say they're layer 7, they still need that data link interface. They need the cable or the virtual cable in and out of that system. And so that fundamentally gives us a power that you won't get in any other system, that we don't need to be in the line of traffic. That just gives you huge capabilities when you start thinking of today's types of infrastructure that are highly distributed, that are highly mobile, that are moving to public cloud. You have very few common points that you can string across all these different infrastructure types, except you need an IP address always, and you need to be able to resolve a name or you will not be able to have a conversation. So that's just a tremendous power that we have, not being tied to the infrastructure.
And that's a great first footing. I wonder if you could talk a little bit more about some of the more advanced features, things in Infoblox that go along the lines of what you were talking about with security, using the NIST framework to really help a customer with their security footing.
So that's an excellent framework because it's very easy to understand and it's widely adapted. If you look at the first building block of NIST, right, you need to identify what are the assets that you're protecting. And you can have discovery systems, you can have agents, but they all need IP addresses. So why not have the IP addressing system tie into the asset identification phase of your security architecture? So that's the first thing. And then everybody needs to do a DNS query to do anything, right? So why not embed the identity of the originator of that DNS query into the actual query? Because believe it or not, that's not part of the DNS standard. So, DNS a lot of times doesn't have the actual sourced information. So that's the first thing we do is we identify all the assets from the IP addressing systems, and then we embed that into the DNS queries.
I'm not sure that everybody knows why embedding the source is so important. Could you just talk to us a little bit more about that? I want people to understand this. This is an important concept.
Absolutely. So if you look at the roots of DNS, it was designed to work in a very distributed system where nobody really knew what was happening in other environments. And that was, by design to some extent, because there were lots of proxy environments and all these types of things. So the net of it is that DNS works in a relay system with hierarchy. So at the top of the .com domain, for instance, TLD, right, top level domain, is a big fat server that knows the translation of every name, every top level domain to some IP address.
It's a master, for lack of a better term.
Yeah, a master. Now, it's highly inefficient and impossible for everybody to speak to that master.
Because you'd kill it.
Right. And even now, there's scaling these systems, the TLD systems is very difficult, and it's only entrusted to a few really trusted providers. So you have to have all these different, relays, and the simplest form, DNS has sort of three phases, right? So there's the internal DNS where everything is, all your private addressing and things like this are known. Then you have the recursive DNS. So when the internal system gets a domain request that it's not authoritative for, right? So your internal system will only be authoritative for a few domains that you own or that are private. It's going to recurse those requests up to another set of relays to eventually get to the TLD. And along the way, there's caching. So the service providers own those recursive servers. And then you have external DNS, which advertises your names that you host out to the world. As things are relayed, they lose the source information. So that's really the crux of the matter right there.
Gotcha. Perfect. So as it goes through this relay from the lower parts of the web to the top, you start to lose some data integrity just based on the design of the system of how DNS works.
Correct. And that's part of the reason that it's lasted for so long, because there's not a lot of information the DNS server needs to remember. It needs to mostly just know how to route queries. So it's a very important scaling aspect of DNS. But, from a security perspective, if you look at all your DNS traffic from your recursive server, the stuff going to the internet, it's going to all come from the recursive server. So you'll lose, very important source identification information from DNS.
So how are you guys, so that makes sense. So we're talking about DNS level security, right? And IP address management, which you can also bind security policy to. Is that accurate?
Yeah.
Okay. So talk to me about how you guys have started moving all this functionality and this core set of concepts. How are you applying this to the cloud and as a SaaS application, no less?
Right. But if you think of those three phases of DNS security, and we're really focused mostly on internal and recursive, I think the first thing you really have to think about in DNS security is the internal. Because the internal is what matters, and that's just whatever's in your perimeter. It doesn't mean it's in your data center. It could be in the public cloud, a private cloud, et cetera. So your DNS security has to start there, tying it to DDI, applying threat intelligence, so you're not going to known bads and things. But as you said, a lot of people are in cloud now. A lot of infrastructure is in public cloud. It's not ever going to touch your assets, and so you need a recursive DNS service that exists every place. So exists in the cloud so that all of your DNS traffic going to the internet goes through one system. So now you can account for it. You can apply security checks. You have an audit point. You can do all types of things from that central recursive DNS layer. So that's one layer, but we've extended that more. Jim, you want to talk about what we're doing with the Blox One DDI with our new SaaS DDI?
Yeah, what I wanted to say is that having that become a private aspect of a company is very important. Is knowing to keep those assets, as far as your DNS queries going out to the internet as much as you can, and the source information so that you can use it to quickly identify how many devices may have malware and what they're querying and what they're going to. Versus what a lot of customers and a lot of people at home do, they just send it to the public, recursive servers that are out there, like Google, 888, and Cloudflare and Quad9. I mean, these are all, companies that want to get your data and use it for their own benefit. Whereas, Infoblox is trying to protect your data, and provide more threat intelligence around that.
Infoblox seems clearly to have a handle on the IP address as like the starting point. I'm sure this is true for IPv4 and IPv6.
Correct.
Yes.
But the idea is that this is a company's complete, comprehensive overview of all of the devices that are on their network.
Correct.
So what are some things when you have that information and when you as Infoblox, you're working with customer X and you have that understanding of their environment. What are some of the things that enabled you to do from a security perspective?
Number one is to share that information. And believe it or not, before you even do security checks, having that central repository that most people have already if they're using Infoblox, and use that as part of your identity policy, that's very huge. And a lot of people don't look at that. So that's one. But the second thing is an overlaying threat intelligence on the DNS queries, right? And then again, tying those queries back to the identity that you get from the IP address system. And then Infoblox takes it a step further, because then we tie the actual addresses to an identity on the network. So, one address maybe it's a VDI. It could have a lot of different, users associated to that. So we can further tag, traffic to a user, not just an address.
Right.
And then now when you find a problem, right? So detecting is important, identify your assets to detect a problem with threat intelligence. But then the real bang for the buck and the real efficiencies that come in for using DDI in security, right? And that's contrasted from securing DNS, right? That's one thing. But now you want to use it in security. And the real bang for the buck, right, is using the DDI system in your automated response. Because since you've detected something and you actually know where it is, and we can correlate that to the user, we can correlate that to the switch port or the virtual switch port or the VPC or whatever.
Because you have such a holistic view of the data, right?
Correct.
In order for your solution to work, you're getting IP addresses and DNS from everything.
Yes.
So because you're so distributed in your deployment, you're going to have all this data to be able to correlate things back and make some determinations that other people can't. All based off DNS queries.
Yeah. And so now we can block any place. We can block you in the data center. We can block you if you're at home. We can contain that threat because, the big mistake that people think, especially for DNS security, is I've bought this cloud service. I'm done. Okay, well, great. The cloud service is telling you, hey, you have ransomware in the network and it's active right now. Okay, great. Well, what host is that? I don't know. And then we blocked it, fine. But ransomware, is going to be doing a couple things at once. It's not just like encrypting one thing. It's going lateral. It's looking for your backups. You need to take that host off the network as soon as possible.
What do you guys do with static addresses?
Oh, we can discover them. Yeah. Hey, I wanted to kind of just kind of give you a real life, kind of a really good example of what Mike's talking about. Let's say, for example, you have a honeypot of some type that's actually looking for, infections. And, it discovers that there's actually some malware that's actually trying to communicate out into the internet, So you have a source IP and a time, that's actually alerted by the honeypot. Well,
Real quick, Jim, for those of you that don't know, because our listeners come from all ages and backgrounds and places, a honeypot is something that you can put out on the demilitarized zone or the public internet to try and entice people to do bad things so that you can monitor their activity and potentially track them back.
Or internal, like TrapX, for example, something like that.
You could definitely sandbox something like that on the internal network.
Right. Yeah, so we have a very strong set of APIs in this very large ecosystem we call, our strength, because, we interface with all these devices, like, let's say, SOARs, NAC access products, and so forth. But, in that example, once you have the source IP and the time it happened, you can go to us and you can say, okay, well, how long was that device on the network? What's its lease window? How long was it there that it was actually pinging that domain? Then you can go off and you can actually then look in our query logs and you can say, well, tell me then how many other IP devices, tried to connect, during that lease window. And then now you can actually have a whole list maybe of, hundreds of devices that are in your network that we've identified in our system because we have that visibility. And now you actually have a shorter time to remediation for what you're trying to resolve.
I get it. If your deployment is done correctly and your products and services are used holistically, right? You have an IP address to asset to distribution point, and now you can draw, you can have network telemetry that is basically complete 360 vision, is kind of what it sounds like you're describing. Is that close?
Yes. Mm-hmm.
Okay. So that makes a lot of sense, and I get that. That's powerful. How are you guys fitting into this new modern workforce scenario, and cloud, right? So how are you guys breaking into those markets, and what's your competitive edge there?
Well, it's basically it's going to be the platform, right? The platform is a cloud native platform built from the bottom up. It's built with micro service technologies. Okay. And we have specific applications that we're running on this cloud platform. And specifically, the first one we've released for quite a number of years now is our Blocks One Threat Defense. That is the DNS recursive service that blocks bad domains and queries and does analytics, for detecting data exfiltration and a lot of things like lookalike domains. Very, very powerful system.
And that's a DNS security. Blocks One is primarily a DNS security platform, correct?
Blocks One is the platform. The Blocks One Threat Defense is the DNS security. Now we just added a new service about 2 years now, which is called Blocks One DDI. And that is actually taking our DDI strength of what we do with DNS and DHCP and IP address management within the network of the customer, and taking it out to the branch and to the locations where it's actually cost effective from a pay as you go concept, and marrying that with the actual Blocks One Threat Defense. So now, as you begin to add another service onto the platform, you begin to be able to leverage the data lake that resides behind that platform, which is the metadata that actually is more useful to the customer to create automations, to create faster, times from remediation of your security, so forth.
So basically, you built this massive data lake of information of DNS queries, ones that are good, ones that are bad, what types of content is behind them, so people can apply policy and other types of filtering and security
and assets.
of
Right.
where that information is allowed to go, what assets is allowed to go to. So, I mean, very granular policies, right?
Right.
Cool.
And as we move forward, DNS tells the story, and Mike does a great job talking about, it's the lifeblood of the future of how, we're all operating, right? It's all based on DNS. It tells you what you're doing.
So something that has come up is the idea of encrypted DNS. I'm curious what you have, what your thoughts are around encrypted DNS, why that is important, and how your solution can really help companies take advantage of it.
Yeah, that's an interesting point right now, because encrypted DNS are referred to a lot in the industry as DNS over TLS or DNS over HTTPS. It's kind of in its infancy, and it's been kind of pushed out the door in a number of different areas, from operating systems levels at Microsoft and Apple, and it's at the browser level with Mozilla and Google, and they have there's different reasons why they want to get your DNS information, because again, it tells a story, right? So if they can actually know what you're doing, then they have better targeting marketing from, let's say if you're Google. Our take right now is you need to secure DNS. So we secure DNS to our cloud. We use DNS over TLS. Take the customer's DNS queries and send them to our cloud for protection. Okay, but we also suggest that customers lock their network to ensure that what's automatically occurring in these operating systems and browsers and getting enabled by default or on purpose doesn't circumvent your ability to know what's going on in your network and being able to see those DNS queries. So to block that is something that we also do really well. So to stop the devices from going to these various different systems. And at some point in time, in the future, there's going to be a standard that everybody's going to agree on. It's going to be called HTTP 3, and that's going to, hopefully help us all be able to know, what's going on in every type of system, from browsers to operating systems, and be able to deal with this in a better manner.
Yeah, but I think the flip side of this, if you think about DNS, right, this is the last system on the internet that's not encrypted. I work in email security when people said, hey, if you encrypt in email, you're going to screw everything up. Well, guess what had happened? If I was in web security, if you encrypt end-to-end web conversations, that's going to screw up things. If you encrypt disks, if you encrypt phones, fill in the blank, right? So invariably, DNS will be encrypted end-to-end. And Jim was saying, it's very common now that the browsers have taken the lead on encrypting DNS. That's because the Chromiums and the web giants have pushed this. But there is an opportunity, and that I think enterprises need to think about is, they need to start encrypting their local DNS, because again, that's just the way the world has gone. It's only a matter of time before the risk questionnaires ask if people are encrypting DNS. So Infoblox provides the capability to run an encrypted DNS service internally, within the internet. And like Jim said, we give very granular controls, so you can control the browser-based encrypted DNS. And by the way, if you look at, the NSA has told every U.S. company, you need to designate and configure an encrypted DNS resolver, for the simple reason that all of these devices, your phones, especially your new Windows 10 and your new Big Sur laptops, they are discovering encrypted DNS services by default. There's a new type of DNS message for the more technical out there, the type 65 and 64. If you look on your network now, you'll see them, and those are discovery tools to find encrypted DNS services. So it's really important that you follow the NSA's guideline and you set up an encrypted resolver and you are able to answer those discovery queries, because if not, you could find that your systems internally are talking to an unauthorized system that's resolving names, and that's extremely dangerous.
So if we put one of those top level domains right? The TLDs we talked about.
Mm-hmm.
If we got them running on Infoblox, would that solve the world's problems?
Well, this is really serious business. You think about it, NSA, there was a quote from Ann Neuberger, she's the head of the cybersecurity director at NSA. And she basically said their analysis highlights that using secure DNS will reduce the ability for 92% of malware attacks from both command and control perspectives, and deploying malware on a given network. Everything starts with a query.
Yeah, right. If you're going to get communication outside, you gotta talk to a DNS, right? That's how they're getting to you. You can't.
Right.
They're not getting. That's how they're getting past firewalls, right? If it was IP based,
that's right.
They wouldn't be getting out.
And it's still a huge problem.
DNS is allowed traffic. It's universally allowed traffic, and if you're not inspecting it to know what's going out of your network as well as coming back in, you're missing the trick, people. What do you think DNS is, folks?
Yeah, excellent point. No, you're exactly right.
It is universally allowed traffic, and if it's not secure, encrypted, and understood from point of origin to point of lookup to response, and somebody could inject themselves in there, you are at risk.
Yeah, secure DNS is one thing, but it's the threat intelligence that you apply to, what you're blocking and what it means when you see a bad query.
Well, because you need to look for the patterns and the bad guys. So that threat intelligence is key. That is the crucial part. Guys, tell us what threat intelligence data is for those of us that don't know.
Well, to me, threat intelligence it's a set of data that you overlay on another set of data, right? And it's as simple as that. So from the point of view of DNS, we're going to look at those DNS queries. And it's very important to understand, right? We're not just going to look at like who you're talking to, like a firewall may look at source and destination. We're going to look at the complete DNS message and be able to overlay lists of things that we know to be bad.
There he goes again, beating up on the firewalls. I can tell what you think, Michael.
But
hey,
that's
for all you people out there that are buying firewalls, you need to stop right now and call Michael.
Yeah. Well, you need to ask yourself the question, is there more to the puzzle? But that's threat intelligence, right? At the highest level, really is that list of known bad, and what really is important is the ability to apply that in real time. And what makes DNS unique, and if you take nothing out of this podcast, right, then take away this simple point that I consider it a malpractice of cyber if you're not running threat intelligence in DNS in real time. And the simple reason for that is that DNS looks at threat intelligence as a zone. So DNS is in zones. So the top level domain of .com is a huge, huge zone file. But that means DNS systems were designed from the beginning to look at very large text files. So we can look at many millions, 20, 30, 40 million indicators in real time and overlay that against your DNS traffic with pretty much zero performance impact, because that's how we're designed. So you have a tremendous opportunity with DNS to overlay threat intelligence at tremendous scale and at very, very low cost.
What do you guys happen to know? What is the delay? What is the latency between the time of discovery, right? Correlation and approval of hey, this is bad. This is a bad pattern. Does it become an active threat intelligence data that's actionable for you to protect my system? What's the time delay between those things?
Well, I'll tell you this. So there's different metrics, right? There's different types of intelligence lists. One of the most important ones is the newly observed domains, right? So, because there is a latency between, something acting bad and something, being identified as bad.
And that's different too, also, Mike, from newly registered domains. Just because you're registered doesn't mean that's going to be bad or that ever is going to be used by them.
Right. But we often find, though, that these newly registered and newly observed domain lists will tag things before they're known to be bad, just because it's something new that hasn't been active on the internet for a while or something like that. So that's one of the immediate benefits, because that time can vary. It can vary from days to hours to minutes. But I was just involved in a threat investigation with a very large company. And, we flag things with newly observed domains. I'd say about 5 days before it ended up, being flagged on VirusTotal and, by other vendors and things like that. So the newly observed and the 0 day sort of behavioral views of DNS are very important because there is that delay. And I've seen it again anywhere from hours to 5 days.
Yeah, it's a difference between being reactive and proactive. I think, with the newly observed domains, you're being proactive and being able to say, hey, this was seen on the internet. We need to block it for this period of time until we know it's either good or bad versus, somebody got an infection. They reported it and now it's showing up on feeds and, it's 5 days in and everybody's reacting to it.
I think that's a good point. And I'm curious in terms of the company and the security posture that you provide, what level of this is automatic for customers and what level of it is something that the customer needs to configure?
Yeah, so the distribution of intelligence, well, first of all, we create intelligence. So we have, the known bad actors, and we track the newly observed entities and domains, and we track lookalike domains and all these types of, semantic variants and things. So that we do automatically, and we enforce all those things, automatically. What the customer needs to decide, though, is what are the risks that I care about, right? Okay, so let's take encrypted DNS as a very easy example. Some environments say I absolutely don't want anybody using a public resolver, and some people say, well, it's okay because we can't regulate that. We have lots of consultants, or we're at school or something. So if you were that school that allowed kids to use a Google DNS or something, you're going to get a lot of alerts, right? And if you're the hospital that doesn't want anybody doing that, then you may get alerts, but you're going to care about them because you need to go tell the people that they have misconfigured their systems. So what the customer needs to do is decide on their priorities so they don't turn everything on. Different organizations will have different policies. So that's the one thing they need to do. And the next thing they need to do is decide how are they going to handle an alert, right? Do they want to block it? Do they want to redirect? Do they want to let it go and investigate? And so these are the types of things they have to decide. And then the third one from dealing with this is you want to share that information with other tools, because the best system to me is, you have a good policy where you don't have a lot of false alerts that aren't important to your priorities. You share those alerts with other systems so that they can take an action throughout the environment and, really automate the heck out of the whole system, right? And not leave a lot to chance. That's the ideal. It's hard to get there.
Yeah, not to go back to the DDI thing, but you mentioned earlier about the static IP address. And I thought, well, we have automations with, sharing this with like a firewall where, if we discover a static IP, we can send that information to a firewall that says, put an ACL in that says block all. Because it should have been a static IP. You only give out administrated or DHCP IPs. Nobody should ever put a static IP out there. Could be some kind of Wi-Fi device sitting on the edge somewhere.
Oh, so you guys are totally against static IP addresses, huh?
That was my main takeaway.
No, I said administered.
Administered.
No, so if we administer it through the IPAM system, then it's
known
approved.
Because it's known.
No,
right?
It's known.
You're saying if someone sets a static IP and it goes undiscovered, that's a risk.
That's where we discover it and we can block it immediately.
Okay, so you guys are scanning. So you guys have a network layout, right? And you're taking all the IP address spaces, and you're just
constantly scanning,
right? And some sort of, is it like just a ping, or?
It's a multitude of techniques, because not one technique's going to do it right. So it'll be SNMP, it'll be ping sweeps, it'll be port scans. Again, a customer can decide how much they want to scan the network. It doesn't really take a lot of bandwidth.
You guys hard on switches? You see a lot of ARP issues? Through your discovery or your scanning processes, I was just wondering, have you ever?
Not so much on the switches. We usually look at the routers. We look at the router ARP cache.
Do you have, as a company, any intention of dealing with things that are not purely IP based, fiber channel, that sort of thing?
Right now, we're focused on IP. I mean, I think, in the OI, in the, the Internet of Things world, there's SCADA and the ICS systems, but so far Infoblox hasn't taken a look at those protocols.
Any closing thoughts? Anything that we should have asked about that we may have neglected?
I think that the main thing again is make sure you run threat intelligence within the DNS system. Make sure you manage those encrypted resolvers and build the DDI system into your automated response platform. You will automate faster and easier than you ever thought possible when you bring the DNS system under your Palo Cortex or your Phantom, your Splunk Phantom or whatever. Any of these things bring us into those architectures. You're going to automate faster, quicker, and cheaper.
Okay, sounds good. Jim?
And don't buy firewalls. I forgot.
Just don't put your false hope. Don't sleep easy. Don't rest easy.
Don't buy firewalls.
Well, they do a lot of things. They just can't do everything. No, I'm going to just go back to just that, the one statistic. Okay. If you put in a secure DNS system with really good threat intelligence, you have the ability to kill 90% of the malware attacks that can occur. And it's not a matter of when you're going to get attacked. You will. You just got to be able to stop it as best you can. And if you can do it at the beginning, because everything starts with a query. That's how they find their domains.
And it really doesn't matter anymore. Established business, new business, like 5-day business, 10-year, 20-year business. It doesn't matter anymore, right? This is, somebody will attack you.
That's correct.
Period.
Yep.
Sometimes I just wonder if people are hearing this message, right? Yeah, DNS is a big deal. It's literally everywhere. And it's allowed communication. Yeah, we should definitely take a look at our DNS traffic.
Yeah, and admit that, the ways that we think we apply security need to be questioned. Maybe it's time for a new approach.
Yeah, I mean, the main takeaway that I have is that we should all be terrified all the time.
At every minute of every day.
Yeah, forever.
Mike, Jim, I really appreciate it. Thank you for your time.
Our pleasure.
Thank you, Chris. Have a great afternoon. Bye-bye.